How important is testing to controlling the outbreak of SARS-CoV-2? Very, very important, of course. Who can't get it right? We can't. We got more on that, and as well, looking at the impact of coronavirus or COVID-19 on the male reproductive organs, bad testes, and bad testing. Hello, everyone. This is Dr. Chris Martinson here with your update on SARS-CoV-2. It is now September in the year 2020. Hard to believe it's already September, but the fall temperatures outside are sort of indicative of that. And oh my gosh, I have so much to do here and to get things ready for winter, including everything from getting places for the animals, got to build a little barn or run in for them, get the garden harvested, all kinds of things. So that's on the side. Meanwhile, I started last time, the prior one video with this. It was as useless to fight against the interpretations of ignorance as to whip the fog. Found this this tweet by Adam Carolla out there. Says, you may know him. He's a minor media star out there. Anyway, says he wrote, turns out the people dying from COVID are old or sick, or both. How many of you pussies got played, and who's going to get played the next time? Forgot the question mark on that. It should be, I guess, a question mark right there. I really have to dispute this point of view, and I know more and more people are putting it out there. It's sort of almost as if idiot signaling was a thing. This would be a signal tweet sent out to sort of gather the masses or something. I guess this is a really indefensible statement here. Just saying it's only the old or the sick. I mean, come on. What kind of a culture are we that we can't even have compassion for people who happen to be old? Hey, Adam, here's a tip. You're going to get old too. So it happens, and as well, that doesn't mean that you should be put out on an ice floe necessarily, if that's where we're going to go with all this. But as well, I've pointed out that when we say the sick are the only ones who are really impacted by this. It turns out that a lot of people have comorbidities that do predispose them, including things like obesity, insulin resistance and a type 2 diabetes or type 1 diabetes, hypertension, cardiac issues, things like that. There's a lot of people who would qualify as sick in this particular story, but we're going to take this story down a direction. I'll see if I can find some common ground, a place where Adam might care. All right, let's carry on. First up, is the PCR test that we've been running the wrong test, or is it simply being used wrong? Interesting article in the New York Times here coming out and asking the question, stating this thing here, your coronavirus test is positive. Maybe it shouldn't be. So the usual diagnostic tests may simply be too sensitive and too slow to contain the spread of the virus. We're going to talk about that so you understand what this means here real quick. In 3 sets of testing data that include cycle thresholds, we're going to talk about what a cycle threshold is in just a second. Compiled by officials in Massachusetts, New York, and Nevada, up to 90% of people testing positive carried barely any virus. A review by the Times found. All right, if you're carrying barely any virus, you are probably asymptomatic or very, very mildly symptomatic, or not symptomatic at all because maybe you're on the tail end of having a asymptomatic case of this virus. So here's the deal. The test can be too sensitive, and that's really what this article is getting at here. So let's talk about this quickly so that we can understand what they're saying here. All right. What is this PCR test? Here's how the PCR test works. So let's imagine here they're talking about a DNA molecule in this particular drawing that I grabbed, but the virus in question is an RNA virus, same process, RNA or DNA. So if this was the virus RNA that was pulled out here that I've just highlighted in yellow, there's a target sequence that we're looking for in this thing. And so the first thing you do is you split the strands, if there are strands. In the case of this RNA virus, it isn't just a single strand. So you come up here and you've got this RNA strand here. You put your primer in, which is a little piece of RNA, matching RNA, that's supposed to match the sequence that you're looking for. That's what gives it its specificity. And when that primer's on there, well, then you can get this DNA, or in other case, an RNA polymerase, in the case we're looking at, that's going to come along, attach to that primer, read it out, and amplify this and make a whole new copy. Well, now you got 2 copies. You got the original copy. Now you got the new one you just made. You run that whole process again. You heat it up. You put this heat-resistant RNA polymerase in there, and then you make more copies. And each one of these is called a cycle. So on the first cycle, we went from 1 copy to 2. And then on the second cycle, we went to 4 copies because we're doubling each of those. And on the next one, we would go to 8 and then to 16. And we just keep doing that, right? So this is the sequence of doublings right here. And the important thing to note is that after 10 cycles, whatever the amount of RNA we had from our virus has been amplified by 1,048 times. But after 20 cycles, it's up by just a little over 1 million. And after 30 cycles, it's just a little over 1 billion. And after 40 cycles, it's just over 1 trillion. So basically, you could just say it's about 1,000x amplification for every 10 cycles, okay, per 10. All right, so that's what's happening here. And that's what the PCR test is. So if you obviously, with 1 trillion, when you've increased the signal by 1 trillion fold, such a huge number, how do we make sense of 1 trillion, right? Big, big number. The question is, where do you make your cutoff here, right? So how many cycles would you run? Because if you just ran this even without any virus in there, any virus RNA, there would be a moment where you would still detect that there was virus in there because you've just amplified the signal. Even if it was a 0 signal, eventually you're going to get a signal out of it. So generally speaking, it's somewhere around 30. 30 is the magic number of cycles, somewhere between 30 and 40. After 40, things get a little goofy on you. So let's look at this real quick because this is interesting, and we want to talk about these cycle threshold values here, all right? And the cycle threshold values, or CT values, is a really important concept here. This comes to us from May. This was in the infectiousdiseaseadvisor.com here. Strong inverse correlation between SARS-CoV-2 infectivity and cycle threshold value. All right, let's look at this. Correlation between successful isolation of severe or SARS-2 in cell culture. So they're isolating this virus from a cell culture. And the cycle threshold value of the PCR test, right, targeting the E gene, suggests that patients with coronavirus disease with a cycle threshold value of above 33 to about 34, they are not contagious and can be discharged from the hospital care or strict confinement, according to a brief report published here in the European Journal of Clinical Microbiology and Infectious Diseases. So, back it up here. They're saying that if somewhere between 33 and 34 cycles, if you have to go further than 34 cycles to detect their viral load, they're really not infectious anymore. You can discharge them. Among 183 samples inoculated, 129 led to virus isolation, with 124 samples having a detectable cytopathic effect between 24 and 96 hours. So they were pulling virus out and looking at its impact in vitro on cells in vitro and said, oh, hey, it's still a viable virus. That's a gold standard test. It's not sufficient that somebody has a PCR test that's positive. You don't know if they still have infectious virus particles in there. And we've discussed that before. Obviously, you could have virus particles that are all inactivated. You could have random fragments of virus RNA in you that from destroyed viruses, things like that. What matters, if you're going to talk about is somebody safe to send home and are they infectious, do they have live virus particles? All right, so they were testing for that. Researchers observed a significant relationship between the CT, the cycle threshold value, and culture positivity rate. Samples with CT values of 13 to 17, remember that's pretty low, only 13 to 17 cycles down here, right? So that would have been somewhere between 1,000 and 1,000,000 times amplification, all led to positive cultures. So the cell cultures were positive. Culture positivity rate then decreased progressively, inversely proportional with CT values to reach 12% at 33 CT value, and no culture was obtained from samples with CT values of over 34. So just declined, down as the CT values went up. That's what the inverse correlation is. As one's going down, the other is going up. And they couldn't get any cultures that were live after a CT value of about 34. Okay, so back to this article in the New York Times. This talks about this now. Now we can understand it just a little bit better. So let's talk about what this article says here. The PCR test amplifies genetic matter from the virus in cycles. The fewer cycles required, the greater the amount of virus or viral load in the sample. The greater the viral load, the more likely the patient is to be contagious. Make sense? Sure does. This number of amplification cycles needed to find the virus, called the cycle threshold, is never included in the results sent to doctors and or coronavirus patients, although it could tell them how infectious the patients are. So you might get a positive test. Your very next question that you should ask is, what was my CT value? And if they say, oh, it was 40, I mean, a ridiculous number like that, or 39 or 38, you might say, I'm safe. I'm safe to go home. I'm safe to be with my family. I'm safe to be out in public, all kinds of things like that. It's a really important number that everybody should ask for if you've got a PCR test and it comes back positive. All right. In 3 sets of testing data that include cycle thresholds compiled by officials in Massachusetts, New York, Nevada, so they do capture that data, the cycle threshold values, up to 90% of people testing positive carried barely any virus, a review by the Times found. On Thursday, the United States recorded 45,604 new coronavirus cases, according to a database maintained by the Times. If the rates of contagiousness in Massachusetts and New York were to apply nationwide, then perhaps only 4,500 of those people may actually need to isolate and submit to contact tracing. One solution would be to adjust the cycle threshold used now to decide that a patient is infected. Most tests set the limit at 40, which is insane, and a few at 37. This means that you are positive for the coronavirus if test process requires up to 40 cycles or 37 to detect the virus. Okay, that's way too high. All right, so we have data that says anything over 33, 34, yeah, it's not an issue. And by the way, I don't know if they're using the exact same test that between what they're reporting on in the New York Times and this report here, an infectious disease advisor that we're outlining here. They might be using a different PCR test. They may have different sensitivities, things like that. But at any rate, assuming they're roughly the same, this kind of data says 33, 34, you're done. Anything over 34, forget about it. Don't worry about it. Not a problem. But we're having test cycles that are running up to 37, 38, 39, even 40 cycles. All right. Continuing on with this New York Times article, they said here, officials at the Wadsworth Center, New York State Lab, have access to CT values from tests they've processed and analyzed. Their numbers at the Times and analyzed their numbers at the Times request. In July, the lab identified 794 positive tests based on a threshold of 40 cycles. 794, that goes right in the column. Plus, look at all the cases we have. With a cutoff of 35, about half those tests no longer qualify. And if we put the cycle limit at 30, that would mean a 70% reduction in the actual number of cases that we would say are positive. In Massachusetts, 85 to 90% of people who tested positive in July with a CT of 40 would have been deemed negative if the threshold were at 30 cycles. So this is Dr. Mina. He's the advocate for rapid home health saliva tests, and I'm in agreement with him about that. So I would say that none of those people should be contact traced. Not one, he said. Other experts informed of these numbers were stunned. I'm really shocked that it could be that high, the proportion of people with high CT value results. Boy, does it really change the way we need to be thinking about testing. Yes, it does. How is this a thing? How is this even a thing? We know that the cycle thresholds, this is from May. This is from May 14th, right? We have this data is all out there. So if you are, the CDC, and you are in charge of testing, the things you're going to be doing is you're going to be making sure about the sensitivity of the test, the specificity of the test, and you're going to be setting the cycle threshold values. And you're going to want those to be consistent across states, and so that we have consistent data, because garbage in, garbage out, all of that. So I am shocked too that we are seeing that there are labs out there reporting positive results with a 40 cycle threshold. 40 cycles is a trillion-fold amplification. That's trillion's a big number. All right, so now we have to wonder about those second waves. It's being reported that a second wave is gripping Spain here. Sounds bad at first, right? At midday on Sunday, 31 patients inside the main coronavirus treatment center in Malaga. The city with the fastest rising infection rate in southern Spain. 32nd arrived in the ambulance. Half hour later, number 33 came in the door. Garbage cans overflowing with masks and blue surgical gloves. My brother-in-law had the virus in the spring. So now she's waiting to hear about her 91-year-old father. Here we go again. You got to read a little further down in this article. It sounds bad. This is the opening paragraphs here. Reading down a little further, we find out, to be sure, doctors and politicians are not as terrified by the second wave as they were at first. The mortality rate is roughly half the rate at the height of the crisis, falling to 6.6% from the 12% peak in May. I'm not sure what this 6.6% is here. Is that a case fatality rate? I hope so, because certainly can't be an infection fatality rate. The median age of the sufferers has dropped to around 37 from 60. Asymptomatic cases account for more than 50% of positive results, which is partly due to a fourfold rise in testing. It could also be due to a fourfold rise in, where's the cycle threshold values? What are they running these as? Because it's entirely possible that you could have what appears to be a giant second wave if you've adjusted your CT threshold from, say, 35 to 40. That might give you a sense that you have a lot of new cases. But here's what we're seeing. They're younger, and asymptomatic cases account for more than 50% of positive results. And by the way, in the first wave, not the case at all. People were coming in. Nearly everybody who was testing positive was also at the hospital with symptoms. So now we're getting a lot more of a readout of how many people are actually being affected by this virus who are asymptomatic, in part because of more testing and maybe because of more sensitive testing, where they're running the cycle threshold values up really, really high. So this, reading stuff about these second waves leads to questions, and those questions are the testing criteria the same as during the first wave? And are the CT thresholds, I've got too many words in there. Are the cycle thresholds the same? CT thresholds, a little bit redundant there. All right, so that's my view on the PCR testing. I think we're going to need, we have to ask some very legit questions about those. And I think the takeaway for me is that if I ever did have a positive PCR test, my very first question is, what was my cycle threshold? How many? So what they'll do is they'll keep running. So let's imagine, here's how it works. You get a nasal swab. The swab goes into a tube. The tube goes off for testing. They put it in their magic PCR machine, and they start running it. And a cycle is a full heating and cooling cycle. And they're going to keep running that until they get a result back that says positive. If they don't get one by some cutoffs, we'll call it 40, they just stop and they say it was negative. But if you got a positive reading on the 15th cycle or the 21st cycle or the 33rd cycle, that's data. And I would want to know that data for myself. And because if I had a cycle threshold where I came back positive way back in the teens, at 13 or something like that, I would be very worried that I had a very high viral load and that I would be in danger of having a more severe case of COVID. So that's it. You would want to ask about your CTs, your cycle thresholds, if you ever tested positive on a PCR test, which would be different from the little home saliva test thing. That's not a PCR test, totally different test. All right, it's time for some junk science here. So named because I like to keep myself amused a little bit. This made the waves recently. A patient with bilateral orchitis. A case report. What is bilateral orchitis? That's itis means it's some sort of an inflammation. And the orchids, orchitis is in the male testes. So this is a case here, 37-year-old previously healthy male came to the emergency room complaining of bilateral testicular warmth and discomfort, as well as the classic cluster of symptoms for COVID: fevers, anorexia, myalgias, fatigue, and non-productive cough. He's got it all except for anosmia, the loss of sense of smell and taste. He noted that these constitutional symptoms progressed for the past 10 days, with bilateral testicular pain developing over the past 3 days. So from day 7 onward from symptom onset, that's about where his balls started to hurt here. The patient was diagnosed with COVID-19 by nasopharyngeal polymerase chain reaction at an outpatient clinic 15 days prior to presentation to the ED, and otherwise unremarkable what they're looking at. Their conclusion from this little report they put together here on this case of one dude, With the progression of SARS-CoV-2 pandemic, rare reproductive complications should be characterized. Identification of infrequent genitourinary effects may help emergency physicians identify this disease at the earliest junction and trigger appropriate treatment, quarantine, and fertility follow-up. All right, we talked about this a while back, and I believe it was this article here. This came out in June. Breaking male infertility. Research shows SARS-CoV-2 coronavirus may indirectly cause testicular damage and also orchitis. So we've been on this for a little while. It seems kind of rare. There haven't been a huge outbreak of cases, but I'm going to show you that the more severely impacted you are by COVID, the more this seems to be an actual thing that we're going to have to really follow up and look at. All right. Here, this was small again. Recent research samples from 11 patients who died from COVID-19 were analyzed by a team here. And the researchers tested for viral genes in tissues involved with sperm, and sperm samples also assessed for damage. However, only one sample out of those showed a trace of the virus, and that was from a patient with a high viral load, and that could have been because the virus was present in blood that was still in the testicular tissue rather than in the testicular tissue itself. So unclear here whether the virus is actually directly replicating in the testes or not. But significantly, more than 80% of the samples showed major damage to the seminiferous tubules. That's the part of the testicles where sperm are made. And it was observed that these cells making up these tiny tubes underwent ballooning changes, becoming much bigger than healthy cells. It's always a bad sign histologically when you see ballooning cells. That's usually they've lost some vital membrane integrity or the ability to maintain themselves in a homeostatic way. Some were also damaged to an extent that sperm production could have been affected, and the researcher said unclear how the virus did this without entering the testicular cells, but noted the testes contain an enzyme known as ACE2. So we do have ACE2 receptors down there. And then more recently, here we see here, well, this was a review, actually. This is coming out at about the same time, back in June. So I got, I remember. I'm going to tell you about the next stuff next. So this was a review here, and what did they find in this review of the literature? They said, well, preliminary findings from studies that are unfortunately not peer-reviewed, so a lot of fresh data was coming out really, really rapid-fire early on. And in published as preprints are linking SARS-CoV-2 to male infertility. There's some 3 references there. But it seems to us that it's premature to make definitive conclusions at present. Yep, I could agree with that based on the date of this. Ma et al. Conducted a study on 81 reproductive aged men with SARS-CoV-2 infection and 100 age-matched healthy men. They found significantly elevated luteinizing hormone levels, but decreased testosterone, luteinizing hormone, and follicle-stimulating hormone ratios. So decreased testosterone ratios. So a lot of luteinizing hormone, not so much testosterone. And that's when that gets out of whack, it's not a good thing, especially for sperm production. They found levels in 81 men with COVID-19, which is suggesting potential hypogonadism. Hypo, less than, under, beneath, smaller than expected output. And hypogonadism, small. That's why we got the title shrinkage up there. But it seems to us these findings cannot affirm whether this alteration is due to direct or an indirect effect of SARS-CoV-2 on the testes. A lot of the effects of SARS-CoV-2 could be indirect. Absolutely. That's a possibility. All right. Indirect meaning, if it's a generalized disseminated coagulation error, right? So you've got microthrombi, you've got clots going on everywhere. Maybe that's it. Maybe it's the same thing that's affecting the brain, affecting other organs. Or it could be a direct effect because the virus has come down, docked on that ACE2 in the testes, caused direct damage. Interestingly, we just had some postmortem findings that just came out in the European Urology Focus Journal here. This is for the September issue. And this is about the pathological findings in the testes of COVID-19 patients and the clinical implications. So what did they do here? They did, again, small studies, but postmortem, after-death examination of the testes from 12 COVID-19 patients was performed. They used light and electron microscopy. immunohistochemistry for lymphocytic and histiocytic markers. So they're looking for things in both the lymph and in the cells of the testes themselves. And they did a little reverse PCR test here just to see if they could detect virus in the testicular tissue. All right. What did they see here? They saw lots of damage to the seminiferous tubules. So I'm going to decode what a lot of these words are in a couple of pictures next. So just hang on and we'll get right to the pictures if this isn't making sense. So microscopically, they saw these things called Sertoli cells showed swelling, vacuolation, and cytoplasmic rarefaction, detachment from the tubular basement membranes, and loss and sloughing into the lumens, or the open spaces, of the intratubular cell mass. Bad news. There's a lot of bad words in there. This swelling, the vacuolation. The vacuole means there's little pockets in them. They look like little tiny vacant spaces, if you will. Cytoplasmic rarefaction, detachment from the basement membranes, loss, sloughing. That's massive cell damage going on right there. So the Sertoli cells looking really bad in these particular things, in the cases here. 2, 5, and 4 of the 11 cases showed mild, moderate, and severe injury, respectively. Okay, so 2 showed mild, 5 were moderate, and 4 with severe injury. The mean number of Leydig cells in the COVID-19 testes was significantly lower than in the control group. They saw 2.2 versus 7.8 with a p-value of 0.001. They're just missing the Leydig cells. I'll tell you why that's important in just a second. In the interstitium word meaning in the space between things, there was edema, which is swelling with water, mild inflammatory infiltrates composed of T lymphocytes and histiocytes. So, hey, there's some sort of damage. Do you have that swelling? That's what the itis and the orchitis usually means, that swelling, that painful heat that one gentleman was reporting. That's when you have inflammation in there, and the white blood cells are rushing in to try and fix whatever damage they're detecting. Interestingly, transmission electron microscopy did not identify viral particles in 3 cases. And the RT-PCR detected virus in 1 of the 12 cases. All right, to decode all of that, let's go to the biology again. Quick reminder, Leydig cells are sitting here in between the place. These are seminiferous tubules, so this would be a cross-section looking at the place in the testes where semen is produced, where the sperm are produced. The interstitial tissue is all the spaces in between these things, in between the tubules here. And these are the seminiferous tubules themselves. All right. When we look at the gonads here, there's a couple of the Sertoli cells are these little ones right in here. They're inside of the seminiferous tubules. Very important jobs. They are regulating the hormone balance. So the gonads are in constant state of both being stimulated to produce spermatozoa and inhibited from producing that. Delicate balance, back and forth. And the Leydig cells here, these are the ones that produce androgens, the testosterone. So, hey, you really don't want your Leydig cells to all get wrecked if you're a guy, and you need to keep your hormones in balance. So this idea that in people who are showing a mean number of Leydig cells, I can't tell from this report whether the Leydig cell count was worse in the severe cases compared to the mild or moderate, or whether it was pretty much global and across all of them. But the idea that the Leydig cells were heavily reduced is a pretty bad sign in this story. So what were their conclusions? Well, they said here, testes from COVID-19 patients exhibited significant seminiferous tubular injury, reduced Leydig cells, mild lymphocytic inflammation. They found no evidence of SARS-CoV-2 virus in the testes in most of the cases, and in none by electron microscopy. And these findings can provide evidence-based guidance for sperm donation and inform management strategies to mitigate the risk of testicular injury during COVID-19 disease course. So, yeah, it's a thing, and it's just yet one more wonderful thing that SARS-CoV-2 seems to be able to dysregulate in the human body. And so perhaps Mr. Corolla will find hypogonadism and reduced testosterone. Maybe he'll find that relevant. I don't know. Maybe that would be something he could he could attach to as a human being and understand that that wouldn't be a cool thing in his life. Don't know. Maybe not. Maybe he just doesn't care. All right, conclusions and summaries here for September 1st. It's I find it very odd that PCR tests have been allowed to be cycled for up to 40 times. It's just somebody who's in charge of testing really ought to have been part of that, saying, nah, if you have to run this 40 times, it's probably not relevant. But even still, we ought to have been looking at that early data that says, beyond what cycle threshold is it relevant to halting the disease or to somebody's disease outcome or their ability to transmit it to somebody else? I find it even odder that the cycle threshold values haven't been a prominent part of the results delivered back to MDs and patients. Doctors and patients, really, they ought to have that data. I would want to know that very much for myself if I had a positive PCR test. As well, those positive tests with the cycle thresholds over 35, say, seem to be useless in helping to halt the spread of the infection. Why? Because, well, you may not have a relevant amount of virus in you that could even be spread very easily or at all, potentially. So this would all be data that would be good to know. And switching over to the other topic, in severe cases of COVID-19, the seminiferous tubules of the testes heavily damaged. That was the findings from those postmortems. But those were postmortems, so those are on people who died. So those are the most severe cases, and that needs to be taken into account. It's entirely possible that for people who don't die, who have much more mild cases, that this isn't an issue at all. So we don't know yet really what the issues are here, but we'll be finding out more and more as we go on, obviously. And we don't know yet what, if any, effect lasting or otherwise this damage in the may have on male fertility. So don't know. We'll just have to keep looking, keep reading, keep being curious. Remember, it didn't have to be this way. We deserve better. We really do. There's no excuse for running testing this badly. Honestly, I bet you anybody listening to this, because you're all the curious, intelligent sort here, I bet you if you're listening to this, you could have figured out where you would have put the cycle threshold value and what would have been relevant. And if you didn't know, you would have put some guidance around that. But for sure, you would have been coaching and counseling doctors and patients to say, pay attention to the CT. It's very important in a PCR test. We don't know exactly where the cutoff lines to this whole thing are, but guess what? If it's over 35, you have less to worry about than if it's under 30. Guaranteed that's a complete statement right there that you can count on. At any rate, remember, who are we, the people who listen to stuff like this and care? Hey, we're the curious, and we're the people who like data, like logic, like common sense, like all of these things at a time when the world seems to be going just crazy. And so how do we identify each other? Well, if you're wearing one of our Peak Prosperity Resilience t-shirts, that's a way. Lots of cool people doing cool things here in these, getting these. And by the way, if you send a pic to info@peakprosperity.com, that email address, we'll put it up on our Instagram page there, and you'll have your picture up next to these other fine folks. Remember, time to harvest your garden. And if you need to, resubscribe to this channel, because guess what? Lots of people are getting unsubscribed from it all the time, and or finding that their notifications have been turned off to this one. So, hey, it happens. It's a thing. Whatever. Just got to deal with it. That's life, I guess, in these modern times. That's all I have for today. We'll be back next time, and looking forward to talking to you then. Thanks for listening, and remember, if you liked this, if and only if you like this, please hit the like button. Helps us reach more people. Thanks very much for listening. Talk to you next time. Bye-bye.
Hi, folks. This is Adam Taggart, Chris's co-founder at Peak Prosperity. To get your own Resilience shirt, simply go to peakprosperity.com/shirts. Each shirt is made of 100% organic cotton and produced in the USA. And when your shirt arrives, please send us a photo of you wearing it if you feel comfortable doing so. We'll add you to our wall of proud Peak Prosperity members who are showing the world that resilience is the way to a better future. Thanks for watching.